This is Chapter 5, Number 9. Two forces F1 and F2 act on a 5 kilogram object. Taking F1 equals 20 newtons and F2 equals 15 newtons, find the acceleration in A and B of figure 5.9. So this is part A, and I've already drawn the diagram. As you can see, there's force 1 right here, and force 2 right here, and the mass, which is 5 kilograms. So first you're just going to set it up with the coordinates like this. As you can see, this is from the 20 from the x coordinates and 15 from the y coordinates. And force equals mass times acceleration. So and this is force, so you would have 20. So once you solve that, acceleration would be but you can't leave it in this format, so what you have to do is try to find the magnitude of acceleration, which is done through taking the square root of so then from that, you would get meters per second squares, and that would be your acceleration. So for part B, I already have the diagram drawn out. So we have force number 2, 15 newtons, and you can see it's at a 60-degree angle as compared to the 20 newtons for force 1, which is just along the x-axis. So you have to break this up into separate coordinates, or excuse me, separate components. So for F1, you would have F1 in the x direction, which is just 20 newtons. In the y direction, which is just 0, because it doesn't go up. Then you have to take the components of force 2, which you break it down. So it would technically be something like so then you would write it down like this. In the x direction, it'd be 15 newtons cosine 60, and then in the y direction, which would just be 15 newtons sine 60. So once you punch it into the calculator, you would get that the x is approximately 7.5 I hat newtons, and in the y direction 12.99 j hat newtons. So then now you have to find the acceleration, and you're going to do the same format that you did in part A. So I got this 27.5 by combining the two x directions. So we have 7.5 I hat newtons, and then the 20 newtons right here, and then plus 12.99 j hat newtons. And this 12.99 comes from combining the 0 j hat here and then the 12.99 here. Would be equal to 5.00 kilograms times acceleration, and the 5 kilograms comes from the object over here, which is 5.00 kilograms. So once you put that into the calculator, you would get approximately 5.5 I hat plus 2.598 J hat meters per second squared. But then you need to obviously find the magnitude of this because you can't leave it in this format. So the same steps are taken like in part A. And put it into the calculator, you get 6.0827 meters per second squared. And you need a degree next to that, or a direction. So the inverse of tangent, and then in the y direction and in the x direction will give you the degree. So then you would get and these two are both from here, and then that would be approximately 25.24 degrees, and this with this would be your answer. And you have to do the same for A. So then this part and this part would be your answer altogether.